tolerance, then so that automatically the reactive power is maintained within this limits. You maintain the reactive power, the voltage value also within the tolerance limit. Then frequency, maintain the system frequency within the prescribed limits. So that the speed of the alternator within this prescribed limit means automatically the frequency value is within the tolerance limit. To maintain these two means the power system is stable. Voltage and frequency are within the acceptable limit. The power system is stable. The next fourth topic, the need for voltage regulation in power system. What is the need for voltage regulation in a power system? First of all, what is meant by voltage regulation? It is the reduction in magnitude of voltage when a full load is applied. Okay, full load is applied. That is full load voltage regulation. When a full load is applied with respect to a full load voltage, that is full load voltage regulation. Full load is applied, the voltage some value is reduced. Okay, the no load to full load, that variation with respect to load, that is the full load voltage regulation. Here the requirements are the need for this voltage regulations are the transmission line and the distribution line need voltage control at various stages to maintain the voltage at this consumer premises within the prescribed permissible limit. With the incandescent line, the below the normal voltage value means the light glow, the illumination value decreases, as well as they draw more amount of current from the power supply. The incandescent lamp's lifetime is reduced. Then motor operations below the normal voltage draw the abnormal high current. Similarly, draw high current will produce heating effects. The motor and the windings will damage. Then also it's more than the rated horsepower. It's carry no more than the rated horsepower load. If the voltage of the system deviates from the normal value, the performance of the device suffers and its life expectancy drops. Okay. If the voltage system deviates from the normal value, that means decreases very well normal value, the motor running performance, the value decreases. The light glowing illumination also decreases. The performance of the system, our expectation is decreased. The real line losses depending as much upon the reactive line as upon the real line power flow. The reactive line flow depends upon the line end voltages. Yes, the reactive power depends on the line end voltages. The line end voltage value decreases means if we increases the excitation power, increases the excitation power from sending end side or generator side, the reactive power flow from the generator side also increases. So this is depends upon the line end voltage. Then next point, by adjusting the excitation of generator at the sending end below the certain limit may result in instability of system, and exceeding the above certain limits will result in the overheating of the rotor. Yes, you maintain the voltage by adjusting the excitation system. You may below value in no load time. You maintain the value means below value means the system instability will occur. Above value supply more reactive power, then overheating of rotor will occur. It also supply more reactive power. Consequently, the voltage value also voltage drop also occurring. Then last point. Service voltage are usually specified by normal value, and the voltage maintaining is plus or minus 5% for the normal value. This is the acceptable limits. The voltage value plus or minus 5% means the voltage value is within the acceptable limit. That is the tolerance limit of the voltage. Then next, need for frequency regulation in the power system. The power system, the load on the power system increases. What happens is the synchronous generator rotor will accelerate and decelerate. Then the relation between the frequency and speed is Ns is equal to 120F divided by P. So that the synchronous generator rotor speed decreases, the rotor angle value increases, that is the load angle increases, as well as the frequency drop will be occurring. Frequency drop, the frequency deviation will occurring. Here some important points are, in any power system, if the frequencies changes, there would not be required receiving end voltage. If we connected two systems in parallel, it will spoil the system. This is the important point. If the two synchronous generators or two power systems are connected in parallel, the two power system frequency must be equal, that is synchronized. Then only it's connected with parallel, otherwise it will spoil the system. Then second point is generator turbines, particularly steam driven ones, are designed to operate at a very precise speed. Yes. Then most of the AC motors run at speed that are directly related to frequency. Because the AC motors, that is the induction motor principles, it produces a rotating magnetic field in the stator. That magnetic field is induced in the rotor. Then rotor also, it's rotate. Okay, the rotating magnetic field, it's that magnetic plus induced in the rotor. Here, the rotating magnetic field rotates at the speed of synchronous speed. Here, the frequency value decreases means the rotating magnetic field decreases. The resultant one is the rotor speed also decreases. Then overall operations of power system can be much better connected if the frequency error is kept within the strict limits. Then a large number of electricity operated clocks are used. Electrically operated clocks are used. That's here using a synchronous motor. If the frequency value decreases, the clock synchronous motor decreases. The time of the clock also vary. The error may occur in this reading. They are all drawn by synchronous motor, and the accuracy of these clocks in the function not only of this frequency error, but actually of this integral of this error. Then step by step this integral. 1 hour that the error value increases, then another hour, then 1 minute again. Integrally this value is continuously increases, requiring large error in case of the electrically operated clocks. Here, for maintaining the frequency value constant, your constant turbine speed arrangements are important. Then unusual deviations in frequency can be detected earlier. When two systems working at different frequencies are to be tied together to make same frequency converting stations or links are required. These are the requirements or need and requirements for maintaining the frequency regulation. There is also a frequency regulation, the drop in frequency from the no load frequency to full load frequency with respect to full load frequency. That is full load frequency regulation. These requirements and these points are to be considered to maintain the system frequency value constant, so that only power system is stable. The voltage and the frequency values are within the tolerance and acceptable limits. The power system is stable. This is the control of power system. The next important topic, that is the real power versus frequency and reactive power versus voltage control loop. This block diagram completely covers the power system control. Here, two control loops are available. The first control loop is real power versus frequency control loop. The second loop is the reactive power versus voltage control loop. The real power versus, first of all, let's consider this block. This is the turbine generator set. Turbine is coupled with generator. Here in our country, in most of the countries, the majority of power plants are thermal power plants. So here consider a steam input energy. That is just the steam turbine. Here the steam power input is given from through the control valve. The turbine rotates. At synchronous speed. The synchronous speed is coupled with the shaft is coupled with generator shaft. So the generator also rotated at synchronous speed. Then here give the sufficient amount of excitation. That excitation means the DC supply is given to the field winding of the synchronous generator. The field winding is the rotor winding of the synchronous generator. Then the rotor rotates. It cuts the stator coils. The EMF will induce. The induced EMFs are three-phase supply. That's are directly given to the line, busbar line, through a power transformer, sending in power transformer. This is the normal operations. It's rotated at synchronous speed. The sufficient excitation is given. That is DC supply is given. Its rotor rotates by the use of this turbine. Then the rotor magnetic fields are cut by the stator windings. Then the EMF is induced. The induced EMF is stepped up by sending a transformer. Then it's directly given to a transmission line for transmission and finally distribution purposes. This is the normal operation. Such a normal operated system, a load on the power system is increases. Load. What is the loads? The different types of loads are used. That's what we discuss in the next topic. The load on the power system is increased. The load increases means